Chapter 8, Friction. All right, everyone. Today we are going to talk about friction, something you all experience every single day. Think about when you slide a toy car on a table. It goes fast at first, but then stops. That's because of friction. Friction is like the invisible hand that tries to stop things from sliding. It always pushes in the opposite direction of where something wants to move. Engineers must understand friction to make sure cars don't skid, brakes work, and ladders don't slip. Now, there are two types of friction we will talk about. The first is static friction, which happens before something starts moving. Imagine trying to push a heavy box. It doesn't move at first because friction is holding it in place. Then comes kinetic friction, which happens after the box starts sliding. You'll notice it's easier to keep pushing once it moves. That's because static friction is stronger than kinetic friction. We also use something called the coefficient of friction, which is just a number that tells us how slippery or sticky two surfaces are. If you have smooth ice, the number is small and it's easy to slide. If you have rough sandpaper, the number is big and it's hard to slide. Sometimes friction is used to stop things from moving, like when you park a car on a hill. Other times, friction is used to move things, like the tires pushing against the road. Engineers use drawings called free body diagrams, where we draw arrows to show all the forces, including friction, so we can balance everything and make sure objects stay where they are supposed to. Friction also shows up in things like wedges and screws. A wedge is like a little triangle you push under a door to stop it from moving. It uses friction to keep the door in place. A screw is like a round wedge twisted into a spiral. When you tighten the screw, friction stops it from coming loose. We can calculate how much force or turning is needed by using simple formulas. Sometimes we have to be careful about tipping versus slipping. Like when you push a tall box, it might tip over instead of sliding. Engineers use math to figure out if something will slide or tip over based on where you push it and how high you push it. In this chapter, we also learn to solve real problems, like finding out how much force is needed to slide a crate, what angle makes a ladder slip, or how much torque is needed to turn a screw. By using simple steps, draw diagrams, write down equations, and solve carefully, we can make sure things are safe. So friction is not just something that slows you down, it is also something that keeps you safe. Engineers use friction wisely to design safe cars, secure buildings, and strong machines. Just like when you wear rubber shoes to stop from slipping, engineers use friction to stop big structures from moving when they shouldn't.